In this video, we're going to talk about midpoint and distance formulas, as well as if we're going to fill out two more of our cards. And the first word is midpoint. So a point that divides the segment into two congruent segments. So a symbol for congruence is an equal sign with a little tilde above it. So sometimes instead of writing out the word congruent, that we can write the symbol instead. So in our picture right here, you can see that segment AB is drawn, and M is our midpoint of this. And the reason we can tell that is these two little congruence lines shows that this segment AM is congruent to segment MB. If the segments are congruent, as it shows in red right here, so the segments themselves, that the lengths of the segments, we just know that those two objects are going to be the same size. That means that the distance from A to M and the distance from M to B will be equal to each other, because distances use numbers, congruence just compares objects together. One of the cards we're going to fill out tomorrow in class is going to say that if M is the midpoint of segment AB, then we know that our AM, so segment AM, is congruent to segment MB, and they'll be on the back, and the reason is because this is the definition of a midpoint. The next definition we're going to talk about is a segment bisector. And a segment bisector is either a point, ray, a line, or a segment, or a plane that intersects a segment at its midpoint. So it does tie into what we were talking about before. So you can see in our picture that the part that is cut in half technically with our midpoint is this segment AB. So that means this green line here, that our line CD is the segment bisector. And it is a segment bisector of segment AB. Because we know it is a segment bisector, then that means that our point M is our midpoint. And if you remember about the last definition, if we know that M is the midpoint, then we know that the segment AM and segment MB are congruent, and that the distance from A to M and the distance from M to B then are equal to each other. So this will be our second card for this section, and we're going to basically say that if we have a line CD that is a segment bisector of segment AB, then we know that AM is congruent to MB, and the reason is because it's the definition of a segment bisector. And we'll fill that out tomorrow in class. Alright, so here's where we're going to practice together, and then the next question you're going to try on your own. So as you notice, it says that point M, right here in the middle, is the midpoint of VW. And we know that the midpoint then, that tells us that the segment VM is congruent to the segment MW, but the length of both of those are equal to each other. So that's how we're going to set up our equation. And this is what our equation will look like. So when we go ahead and solve it, we can move the 3x to the left-hand side. And we did that by subtracting, so now we end up having an 1x on the left, and then we still have a minus 1 and a 3. So now we can move the minus 1 to the other side. So we can do that by adding 1 to both sides. And this gives us a positive 4 for our x value. But if you reread the directions above, and this is going to happen quite often, that we don't want to just find the x value, we need to find the length of segment VM. So segment VM is right here, so that's this 4x minus 1. So we need to take our value for our x equals 4, and we need to substitute it back into this portion of our equation. So our result ends up with our distance from V to M is 15, so that means that the length of segment VM is 15. This next question is for you to try, so if you notice, you want to find the distance from P to Q, so the whole segment, when M is the midpoint. So you have to think of what does M tell you about the midpoint, about the two different sections. You can set up an equation, solve for x, but then we need to find the length from P to Q. So you have to substitute that x value back into actually both of these segments. So push pause, and when you're ready to check your answer, you can push play again. Alright, so when M is the midpoint, that tells us that we can say that this segment MP or PM is congruent to segment MQ, but then our distance from P to M is equal to the distance of M to Q. So this gives us 5x minus 7 equals 11 minus 2x, and when you solve it, if I move my 2x to the left-hand side, I would add that over, so I would get a 7x on the left. And now you can move the positive 7 that is a minus 7 right now. If you move it by adding it to the right-hand side, that would give us an 18 on the right. And then to solve for x, I need to divide both sides by 7. So this gives me 2.57 around, or I can just leave it as a fraction as 18 over 7. Now remember, we need to find the distance from P to Q. So we need to take this value of our x, and we need to substitute it into the 11 minus 2x and into the 5x minus 7, and then combine those two answers. On the left-hand side, this is the segment PM in green, and once I multiply by 5 and I subtract 7 from that, I end up with 41 over 7. On the right-hand side, after I multiply 2 times 18 over 7, and then I take 11 minus that answer, I also get 41 over 7. But now I need to combine these two answers together, since this only gives me each of the individual segments and I want the whole length. So either I can add them together, or I can multiply one of them by 2, and I end up with 82 over 7, or I get 11.7 around for my answer. Alright, so this next formula is the midpoint formula, which you've probably used before. It's basically find the average of the x's and the average of the y's. So if you find the average of something, you add them together and divide by the number that there are. And since when we find the midpoint, we're only using 2 points, that's why in your formula you are dividing by 2 for each of those, because you're only adding 2 numbers together. So in this first one, we're going to take our 1 plus our 4 and divide by 2. And then for the y value, we will take our negative 3 plus the 2 and then also divide it by that 2. And this is what it would look like. So when we do this, the left-hand side, we need to add the top and then divide by 2, so we get a 5 over 2. The red, we get a negative 1 on top and then divided by 2. And then we'd get our coordinate m as 5 halves and negative 1 half. So when we find the endpoint for the next situation, this situation, they give us the midpoint and only one of those endpoints. We have to work backwards to find what the original endpoint was that would give us the midpoint of 2, 1. So we're going to use the idea of this equation, and we're going to set up 2 different equations and then solve for the x and the y in those equations. So in the first one, this is what the x equation would look like. So you see in my equation, this 1 came from the j, from the endpoint. The x is actually from the missing x we do not know for our endpoint k, and then the 2 is just from the equation itself up here. The blue 2, if you see, is what our ending number should end up being. So if I took the 2 endpoint x's and I add them together, I divide by 2, I should end up with a 2. So we're going to set up a similar equation for the y values using the 1 and the 4, and then our 2, and then the missing y. So you can see in the red that the original endpoint and our y value we do not know is added on top. We're dividing by the 2 from the equation up above as well. That's in the original midpoint formula, and then it needs to equal the y value that we know that the midpoint is. So now we have 2 separate equations that we can solve, and I would suggest to make this easiest, if you put the 2 over the 1 and a 1 over 1 to make it a fraction, that you can then cross multiply. So that is one way you could do it. So you would multiply then our 2 times the 2 on one side of our equation, and then 1 times 1 and 1 times x. One way you could get rid of this instead is, because it is just dividing by 2 on the left, if we just multiply everything by 2, that would eliminate the 2. So that's the way I'm going to go about doing it. So on this left-hand side, because I am multiplying by 2, that the 2's on the bottom, that was dividing by another multiplying 1 disappears, so I get a 1 plus x on the left. On the right-hand side, this 2 times 2 on the right-hand side now becomes a 4. And now all I have to do is subtract my 1, so I end up with x equals a 3. So my x value of my coordinate of my endpoint for point K is a 3. So I do the same idea for the y values. If I multiply both sides by a 2, that gets rid of this dividing by 2. So now I end up with a 4 plus y equals a 2, because 1 times 2 on the right-hand side gives 2. So if you look at the original endpoint, so 1, 4, and 3, negative 2, if you do the same midpoint equation, the actual midpoint equation from up above, you would end up with 2, 1. So that's the way you can check it. Alright, so this is the way for you to check to see if you understand how to do these questions. So after you get done writing these down, and you can push pause, and then you can push play when you're ready to check your answer. Alright, so for the first one, if we are just finding just the midpoint in general of segment A and B, we can just go straight for the midpoint formula. So we're going to add our 1 and our 7 together, divide by 2, add the 2 and the 8 together and divide by 2, and this is what your equation and work should look like. So the way this is set up, that means that our midpoint, point M, is going to be at the coordinate 4, 5. So on the second equation, when you figured it all out, you have to work backwards to find out what the endpoint is. So the original endpoint that they gave us, the one of them was 4, 4. So if you use that and just plain x, y for your equation, and each of those equations then should equal each of these x and y values. And this is what your setup should look like. Once again, probably the easiest way of solving this is if you just multiply both sides by 2. That eliminates the denominator. So now in your x equation, you would have 4 plus x equals a negative 2. So x is going to equal a negative 6. For your y's, you would have a 4 plus y equals a negative 4. So when you subtract the 4 from the left, you would end up with a negative 8. So your coordinate for endpoint V would be a negative 6, negative 8. All right, so these are the last two questions that you're going to be doing, so one together and then one on your own, and this is using the distance formula. So one way we're going to do it, we're not actually going to use the distance formula. I'm going to show you how to use the Pythagorean theorem on a drawing of a graph instead, because it actually works a little bit easier and there's less mistakes that happen with it. So what we first want to do is we want to graph the two coordinates that are given on the graph. Next, we want to connect them together, which is a straight line. And then we want to make two sides to a triangle. We can either go across and then down, or we can go down and across. Somehow we need to connect those together using just following the dotted lines on our graph paper. So it doesn't matter which triangle you do. You can do the one on the top or the one on the bottom. And I ended up doing the one on the bottom. So then we want to count the number of boxes that make up each side. So the boxes up and down and the boxes across, because we're trying to find the distance across here, the hypotenuse of our triangle, but we can count just using the boxes on the left and right. So up and down, our triangle uses 6 boxes, and across it uses 4 boxes. These values are then the A and the B value for for the Pythagorean theorem, which means that we're trying to find the side C in our Pythagorean theorem. So this is the setup we should be using. So 4 squared plus 6 squared equals C squared. So we want to simplify each of those individually. So 4 squared is 16. 6 squared is 36. Then we can add the 16 and the 36 together, and that gives us a 52. And if you remember from last year, that the way to undo something that is squared is we need to take the square root of it. And when we take the square root of it, that means that the square root and the squared cancel each other out, so we're left with just the C. So the square root of 52 is what our C value equals, and that is around 7.2. So C, which is really the distance of our S, so from R to S, that it is around 7.2 units, and that's our letter D answer choice up here. All right, so this question you're going to try on your own using the same method, so don't use the distance formula, but I want you to try making a right triangle on the graph after you graph the two coordinates, and then you want to connect those together, and then use the Pythagorean theorem to figure out which of these answer choices is the distance from point A to point B. So push pause, and when you're ready to check your answer, you can push play again. All right, so now that you're ready to check your answer, this is what your graph should look like with your counting values. So in this triangle, it just happens to be the same values as before, so we're still going to take our 4 squared plus 6 squared equals a C squared. We already know that those two numbers added together gives us a 52. We have to take the square root of both sides to cancel out that squared. So our C, again, is the square root of 52, which is a 7.2, which is our answer choice of B up above. All right, remember to bring all of your notes with you to class tomorrow, and we will work on filling out the 2 note cards from the first 2 definitions. See you then.